There are two methods are there to find the tuning parameters. Two methods. One is called open loop method. Or this can also be called as reaction curve method. You obtained the reaction curve in the level process. In open loop, you gave 5% change at the nominal level. Nominal level means the level at which you always want to control. That you got a curve, S curve you got. For that open loop change, you will get a curve like this, S curve. It is looking like S, that's why S curve. This curve is called a reaction curve. That's why this method is called open loop method or reaction curve method. So for level process, we will use open loop method or reaction curve method. Another method is closed loop method. Closed loop method or sustained oscillation method. Sustained oscillation method. Sustained oscillation method or closed loop method. This method is reaction curve method. This is applicable for level process because level process is very slow. That's why we are applying open loop method. For fast process only, we can use closed loop method. For slow process, we cannot use. Why we will see now. In control system, you might have studied that. Have you studied root locus? In the root locus, real axis, imaginary axis. If you draw a root locus means, suppose I want to draw a root locus for third order process. Third order process. Third order. This is a third order process. What is the root locus for this? 3 root locus branches. How many branches? 3 poles mean 3 root locus branches. Am I correct or not? One will go to infinity like this. Another one will go like this to infinity. Another one will go like this to infinity. Am I correct or not? This is the root locus. What is root locus? Locus of poles as k varies from 0 to infinity in closed loop. This is third order, you know. S cube plus A S cube plus B S square plus C S plus D. Third order. Am I correct or not? Third order transfer function. Yes, A S cube plus B S square plus C S plus D. I am taking this. Set point is given here. This is cross variable. In control system, you are calling this as reference. This is response or output in control system. Here, this is called set point. This is called cross variable. Okay. Both are same. Here, how you obtained this root locus? Let us assume that for this transfer function, you got this root locus. How you obtained is by varying this k, you plotted the poles. You plotted the poles because this is open loop transfer function. In closed loop, what is the closed loop transfer function? If you write the closed loop transfer function, it will be looking like this: AS cube plus BS square plus CS plus D plus K. Am I correct or not? Denominator, you will get K. That's why you are the pole is varying pole you got. If you vary K, the denominator poles are moving. That is root locus. If poles are on the right hand side, the system is unstable. So even though you are varying numerator K, the system becomes unstable. The system becomes unstable. When at this point of value, that point is called K max. At K max, it transfers from left hand side to right hand side. Left hand side to right hand side. That's why the system becomes unstable. System becomes unstable. At this point, the system becomes unstable. K max. If K is greater than K max, system becomes unstable. So we should not put any system in the verge of instability. If you put this at this point, the system will always oscillate. The output will be like looking like this. I did the experiment on RC phase shift oscillator. How many phase shifts you are introducing? 3 phase shifts, 60, 60, 60. 180-degree phase shift. The amplifier will give 180-degree phase shift. Total phase shift how much? 360. Total gain 1. That's why it always oscillates. Actually, in the lab, what you are doing is you are calculating R value, C value. But either R or C will be fixed. You will calculate either C or R. Am I correct or not? You find that value, you put that value. But if you see at CRO, no oscillation. Why? You are calculating correctly. You got that same value of capacitor there. If you connect it, it is not oscillating. Why? Huh? Oh, no, unstable maybe. Maybe unstable, maybe stable. We do not know. Consider, no problem. Why it is not oscillating? You calculated correctly. Your calculation, no wrong in your calculation, but it is not oscillating. Why? Why? You calculated correctly, no? Because you put 3 phase shifts here, 60, 60, 60. The components that you are using has how much tolerance? 10% tolerance. You are getting 1 kilo ohm means it may be 900 ohm to 1100 ohm. It is not correct. 10% tolerance. Sometimes 5% tolerance means it varies from 950 to 1050. So it has tolerance. That's why even if you put correct value, it is not correct because it has some tolerance. That's why you will be given one part. You will adjust the part. When you adjust that part, this oscillation comes. Am I correct or not? Because the poles should be exactly on the j omega axis. In the lab, what you are doing is, maybe here means you said unstable, why the answer is not correct means sometimes here means no sustained oscillation. It is before that j omega axis means no sustained oscillation. Initially, small oscillation you might have seen, after that it settled. If it is here means it goes to unstable, either it goes to cutoff or saturation. Here it works as amplifier. In this part, if the pole is in the left hand side, it works as amplifier. If the pole is on the right hand side, it works as either cutoff or saturation. If exactly on the j omega axis, then only it will exhibit oscillation. So in the lab, you are adjusting the pole so that it will be on the j omega axis. Both subjects are same. You are reading different way. Both are same. There you are saying that closed loop phase shift must be 360. Total loop gain must be unity. Bargusan criterion. Am I correct? Bargusan criterion. The same here. But here we are studying in different dimension. So if it satisfies the Bargusan criterion, that is for a particular value of K, it exhibits sustained oscillation. That is K max. Here we should not give K max. If you give K max, you cannot settle. Always it will oscillate. The process always will oscillate. It should settle. That's why K max is the maximum value that can be given. So for safety, it should be far, far less than K max. It should be far, far less than K max. A factor of safety is required because for resistance, you have tolerance. For capacitor, you have tolerance. For every mathematical model, there is a tolerance. You obtain this process, you are getting some model and you obtain a tuning parameter, it may be wrong. That's why we should far away from the oscillation mode. Far away from the oscillation mode. If you know K max, you can use only 50% of the gain so that you are safely away from unstable. That is called relative gain. Relatively, I am 50% away from unstable. Are you able to follow? Suppose this beam here, this beam, actually this much size beam is not at all required. For one day use, suppose this building is used only for one day means this much is not required. 1/6 of this is sufficient. How much? For this much load, 1/6 of this is sufficient. But they are putting 6 times higher. Why? Factor of safety. Factor of safety. So the building is designed for 6 times safer than required. Because if any earthquake comes, it should withstand. That's why the buildings are designed for 6 times higher than required. You understand this? Theory, civil students will calculate what is the required amount of steel. They will calculate and they will multiply by 6. That's why if it is constructed by mason, the building is strong. Because how much it is higher? 6 times. Any small error will not affect. You understand this? So here, our controller gain must be 50% less than Kmax. Or the gain margin must be 2. Have you studied gain margin, phase margin? In control system, this is the meaning. Gain margin 2 means, linear scale 2 means, you are 50% away from the unstable. If you multiply the gain by 2, it becomes unstable. That is the meaning. Gain margin 2 means, if you multiply the K by 2, it becomes unstable. In the verge of instability, not unstable, the verge of instability, it means always oscillation. Always oscillation. So, we have to find that point. How to find that point? That is Kmax. If you find Kmax, we can find the tuning parameters. That is another formula. In the previous case, in the level process, how we find Kc? Kc equal to time constant Tp divided by Kp multiplied by Td. Am I correct or not? Multiplied by 0.9 Kc. Ti equal to what? Ti equal to 3.33 times Td. Am I correct or not? 3.33 times Td. Here, Kmax, if you know, you can find Kc. Kc equal to 0.6 times Kmax. 0.45 times, sorry. 0.6 is for PID controller. This is 0.45 times Kmax. Only 45% is used to gain. So Ti equal to Tu divided by 1.2. Tu means it is oscillating, you know. It is oscillating. Find the period of oscillation. For one oscillation, how much time it takes? That is called Tu. That is called Tu. If you know Tu, divide by 1.2, that is Ti. This is found by Ziegler-Nichols. Ziegler-Nichols. 2 scientists found this. Ziegler, one person named Ziegler, another person named Nichols. That's why it is called Zn formula. Zn thumb rule. Those days, he found in 1949. When they found the formula, when 1949. That time, no electricity. They will use this 3 to 15 psi signal will be used to transfer measurement. If they measure 100% measurement means they will send 15 psi. 0% measurement means they will send 3 psi. 50% means 9 psi. That signal used those days. That time, the PID controller can be tuned by using these 2 formula. They gave the thumb rule. This formula and this formula they found. No one accept that. Like if the earth is round, they said, what happens to them? They're murdered. No? Like that, they didn't accept it. But nowadays, everyone is using this formula. Everyone is using this formula. But Indians are not like that. Indians know 1,000 years back, earth is round. That's why they wrote Panjangam 1,000 years back. They know the movement of earth. How it works and all they know. It means that 23.5 degree inclination they know. They know sun is in the center. If you go to temple, 1,000 years back it is constructed. But where they put the sun? In the middle. They know all planets are rotating the sun. They know 1,000 years back. But in Europe, anyhow, We are far, far intelligent than anyone in the world. That's what I'm telling. Say, Ziegler-Nichols found that formula. That is still used here. Thumb rule. It is thumb rule. So it is used by considering the gain margin, phase margin. Considering gain margin, phase margin. K max we have to find. How to find K max in this experimental setup? That you will see now. For that, this controller, we have to put the controller in closed loop initially. Put the controller in closed loop. Give some set point. Put the controller in closed loop. Give minimum gain. Give minimum gain. Because it is not Kmax. Give minimum gain. It means give maximum PB. What is the relation between PB and Kc? PB equal to, already we have seen, PB equal to 100 by Kc. Or Kc equal to 100 divided by PB. We are going to enter in terms of PB means inversely proportional. Kc infinity means PB 0. Kc infinity means PB 0. Kc infinity means PB 0. So for maximum gain, you have to enter PB equal to 0. So you can enter any value. For minimum value means you enter 100, 200, 300 like that. If you enter 100 means PB equal to 100 means Kc equal to what? 1 unity gain. So small gain, enter 400, 100 by 4, 1 by 4, 0.25 gain. Enter and put P only controller. Because we have to find, what we are finding? K max. At what time it exhibits sustained oscillation, we have to find. That's why put P only controller. Don't use I mode. Only P mode. Put P only controller here. Here put P only controller. P only controller. It means proportional controller you put. Gradually increase the gain. It means what? Gradually decrease PB. At one point, it exhibit oscillation. It will exhibit sustained oscillation. Means amplitude is constant. It exhibits oscillation. Note down that K max. Find the period of oscillation. Find the period of oscillation. That is called TU. The value at which it exhibits sustained oscillation is K max. You got K max. You got TU. You can find the formula. You can find the formula. That's all. Tuning is over. What is the formula? Already I told you that Kc equal to 0.45 K max. Ti equal to Tu divided by 1.2. Now, how to find Tu we have to find. You can find K max just in the controller. You are decreasing PB. You are decreasing PB. At one point, it exhibits sustained oscillation. That is the required PB. That is PB min. Kc means we have to tell max. PB means min, minimum. PB min you will get that you have to divide by 0.45. If you multiply Kc max by 0.45 means, PB means you have to divide by 0.45. So you got PB min, you got PB, required PB equal to PB min divided by 0.45. I got PB. How to find Ti? Ti equal to Tu divided by 1.2. How to find Tu? For that, the flow rate is going through this. The DPT measures flow rate in terms of 4 to 20 milliamps. Here, have you studied rotameter? Suppose a rotameter is here. Let us assume that one rotameter is here. This is the rotameter. Rotameter means one bob will be there. One bob will be there. Depends upon the flow rate, this bob will be there. If it exhibits sustained oscillation, flow rate is going increasing, decreasing, means what will happen to the bob? It goes up and down. Goes up, again come down. Again goes up, then come down. But it should go to the particular mark and come down to particular mark. Then only it is sustained oscillation. Otherwise, if the oscillation is like this, let us assume, it means future it will settle. It is not Kc max. Less than Kc max. Another one is it goes like this. Go on increasing, but it cannot go beyond 100%. Goes to maximum, come to minimum, but if it is greater than K max, this problem will come. This is called, can be found by, this can be found by, it goes up and stays there for some time because it cannot go beyond 100%, you know. That's why it stays there for some time, then come down. And come down and stays there for some time and goes up. It means you whatever value you gave is greater than K max. So it will go up and immediately it should come down. That is called for value for which it exhibits sustained oscillation is called K max or PB min. You got PB min. TU, how it can be found? It goes up and down. It means it exhibits sustained oscillation. So measure the time. Stop clock will be given. You can find the time. If you measure for one time, it will be error. In a physics experiment and all, what you will do in the pendulum, they will measure time for 50 oscillations or 20 oscillations. You will be asked to find. Then you divide by the 20, you will get the average value. So error free. Like that, this bob goes up and down 10 times for that measure the time. Divide by 10, you will get for one oscillation, TU you will get. Now you got TU and K PB min, you can find the tuning parameters. You understand the point? Now I will tell you, this is the experimental setup. I will tell you how to do the experiment. The experimental setup is given. VFD means what? A variable frequency drive. What it will give? Depends upon 420 milliamps. Its frequency varies. Based on that, pump speed will be there so that no power loss. And DPT measures the flow rate, actual flow rate. It compares with the set point and gives errors. Error is given to the controller. Based on that error, the controller gives output, M, 420 milliamps. To do this experiment, we have to put the controller in auto mode directly. Because since it is the fast process, directly put the controller in auto mode, give some set point, give minimum controller gain or PB maximum, gradually decrease the PB. At one point, it will exhibit sustained oscillation like that. It means in the rotameter, the bob will go up and down for constant amplitude. Note down, this phenomena is called limit cycle. Now I remember the name. Limit cycle means it goes up and stays there, then come back. If you give greater than K max, limit cycle, it should not be limit cycle. So you gradually decrease the gain. At one point, it exhibits sustained oscillation. Find PB min and TU, ultimate period. U means ultimate. T max or TU, ultimate period you will get. Divide by 1.2, you will get TI. So enter those tuning parameters, and then if you vary the set point, the flow rate will be automatically fixed by the controller. The flow rate will be fixed by the controller. How to give disturbance? We have to do two experiments, you know. One is servo, another one regulatory. Servo means you can change the set point from 50 to 55. You will get servo response. How looks like? The servo response is looking like this. Servo response for flow process is looking like this. Initially, it is at 50%. You change it to 55%. Set point is changed. That's why it goes up and oscillates and settles. This is servo response. Servo. Regulatory response means here one tap will be there. Hand valve will be there. It is here. Actually, it is here. Before that rotameter, one valve is there. You slightly close that. Actually, you are introducing some resistance in the tube. That's why flow rate will decrease. Or if you open, resistance will decrease. That's why flow rate will increase. So you are introducing the load here, disturbance here. If you introduce that disturbance here, what will happen? Suppose you are opening more means flow rate will increase 50% initially. It increases. That's why controller takes necessary action and controls again to 50%. Again, since it is a PI controller, it will be settled. You can check for P controller whether it works or not here. If you deliberately put P only controller and give some set point, definitely now it will settle. Suppose in a servo response, it is initially at 50%, let us assume. You are giving 55 means it will go up and settle at some 54. Typically, I'm telling, maybe it may not be correct. Experimentally, it will settle somewhere before 55. It never settle at 55. P only means this is P only. You can check in the flow process because it will settle quickly. That's why you can do that experiment. In level, you cannot do such experiments. You can do, you need a long time, but you are provided with only 3 hours. That's why you cannot do. Here you can check P only. If you put, there will be a steady state error. This is called steady state error. You might have studied steady state error in control system. Steady state error will be there. If you disturb, suppose I am disturbing the process with the P only controller means, if I disturb, initially it is at 50%, say 50%. This is cross variable. Initially it is at 50%. At this point I disturbed, it goes out and oscillates and settle like this. It may settle at somewhere 52%. Steady state error will be there. If P only controller, if you use PI controller, there won't be any steady state error. Have you understand this point? This is your second experiment. The third experiment is modeling, tuning, and closed loop control of soft process.